This video is going to look at just the introductory trig functions that are used for right triangles. So starting with a right triangle, you do have two legs and a hypotenuse, but when you start referencing these angles and the sides in reference to those angles, then some different words get brought into play. So if we have, if we were looking at angle A, and focusing on the fact that there's an adjacent leg and there's an opposite leg. Opposite meaning across from, adjacent meaning next to. And the hypotenuse is always the hypotenuse. It doesn't change with respect to where or whichever angle you're looking at. If you were to look at angle B, then you have the leg below it is adjacent to angle B and the other leg is opposite. So the opposite and adjacent relationship is completely dependent upon which angle you're referencing when you go to set up the ratios for the trigonometry. So what we have for those, there are three of them. They're called trigonometric, which we'll use shortened trigonometric functions. We're focusing on three for this section, and they are the sine function, the cosine function, and the tangent function. And those all have abbreviations. Sine function is abbreviated SIN, cosine is abbreviated COS, and tangent uses the abbreviation TAN. They match the buttons on the calculator, which we'll use to calculate some of these function values or maybe finding angles. And for those functions, there are these ratios that are created. And ratio, remember, is just a fraction of two values. So what the sine function does is it creates a ratio on an angle. So whatever angle you're looking at, and a lot of times they'll use this, it's a theta, it's a lowercase Greek symbol they'll use to indicate the angle. So if you're looking at the sine, cosine, or tangent of a given angle, then what you end up having are these trig ratios. And the sine ratio takes two pieces of the right triangle and it puts the length of the opposite leg and it divides it by the length of the hypotenuse. The cosine ratio takes the length of the adjacent leg and it divides it by the length of the hypotenuse. And the tangent ratio takes the length of the opposite leg and it divides it by the length of the adjacent leg. And that's all the sine, cosine, and tangent trig ratios are, depending on which angle you're looking at, whether it's, angle A or angle B or whatever angle it is. It'll never be angle C for right triangle findings. But either of those acute angles, all that equals is a ratio of two sides of that right triangle, and it'll be your job to pick out whether or not it's opposite, adjacent, or hypotenuse. And there are some mnemonic sayings that a lot of people have been taught over the years. One is Sohcahtoa, where, if you break off the so, it's the sine is opposite over hypotenuse, the ka is the cosine is adjacent over hypotenuse, and the toa is representing tangent is opposite over adjacent. It's just pulling those beginning, SOHCAHTOA to sort of have a mnemonic device to help you remember how those ratios get set up. There are many others. I have presented them in a PowerPoint that is online, so you're welcome to view that. But when you have to answer questions in the very, very beginning with the initial setup, you're asked to give and find exactly what the sine, cosine, and tangent of certain angles are. So for example, if you had that really nice basic 3, 4, 5 triangle and angles A, B, and C, and you were asked to find the sine of angle A, it is literally just the ratio set up for the sine of that angle. So the sine function is a ratio of opposite over hypotenuse. So with respect to angle A, the 3 is opposite and the 5 is the hypotenuse. And that would be the exact answer for the sine of angle A. If you were to give a decimal answer which sometimes they'll take, but otherwise you'll need to give exact. 0.6 is the decimal answer for that. If you were finding cosine for angle A, it is the adjacent side that's touching A divided by the length of the hypotenuse, so you would get 4/5, or 0.8. If you were to do the tangent of angle A, that's the ratio opposite over adjacent. So in reference to angle A, again, it's in reference to that angle. Opposite of angle A is 3, adjacent to angle A is 4, so it's 3/4, or 0.75. Okay. In the event it asks for it in reference to B, your opposite and adjacent relationships would change, but you would still have very similar answers. Say you have the triangle where this side is 1, one leg is 1, the other leg is 2. We'll mark the angle in the bottom left corner, and I want to find the cosine of theta. Okay, in reference to theta, cosine is adjacent over hypotenuse, and currently I don't have the hypotenuse, so we'll have to use Pythagorean theorem to find it. So we'll come down here. I have both legs. What I don't have is the hypotenuse, so that's what I'll solve for. So I have 1 squared plus 2 squared equals c squared. 1 plus 4 is 5. So my missing hypotenuse is the square root of 5. And I'll leave it because that's exact, and that's my hypotenuse. So now I can come back to my cosine ratio and pull from angle theta. Adjacent to that side is 1, or to that angle is 1. And the hypotenuse is the square root of 5. That you are welcome to leave as an exact answer, even though the square root is in the denominator. It is taken as an exact answer for your online homework submissions, and you're welcome to leave it like that without having to rationalize the denominator. Otherwise, you can give the decimal approximation of 0.4472. But exact is what will be expected on a lot of those questions. Tangent of that angle, if you had to find it, is the ratio of opposite over adjacent. So in reference to the angle theta that's been marked, opposite leg is 2, adjacent leg is 1, and 2/1 you would write as 2. The sine of that angle is the ratio of opposite over hypotenuse. So in reference to angle theta, opposite is the leg of 2, and the hypotenuse is the square root of 5, and that is how you are welcome to leave the exact answer. The decimal approximation is 0.894. Okay, so sometimes you will have exact answers with square roots, and sometimes you will have answers where you're allowed to give the decimal of those values. And again, sometimes you're given all 3 sides, and sometimes you actually have to find either the hypotenuse or maybe you're missing a leg, and you'll have to use Pythagorean theorem to actually go through and calculate what that missing side is, so that you can go through and correctly give the trig ratios. Okay, but that's just an introduction to the sine, cosine, and tangent functions in a right triangle, and using those functions to come up with those ratio answers. Again, no sine, cosine, or tangent buttons were used in the making of this video. All you're doing is simply setting up the ratios of side lengths and giving those exact or decimal approximation answers.